Ever since Boston Dynamics first introduced Atlas, it's felt like we were watching a long, fascinating chapter in robotics unfold. Now that chapter is wrapping up as the company shifts its focus toward a new electric production version designed for real factory work. Before moving on, Boston Dynamics teamed up with the Robotics AI Institute to push Atlas one last time, really testing just how far its full-body movement and control systems could go. The demonstration starts off simple enough, with Atlas casually walking around an open space. The way it moves is surprisingly human-like, with each step balanced and natural. But things quickly get more impressive when the robot suddenly launches into a cartwheel. It moves sideways with its arms and legs working together in perfect coordination, keeping its balance the entire time. That cartwheel smoothly transitions into a backflip, where Atlas tucks in, spins through the air, and lands cleanly on both feet. Even while flipping, the robot stays tight and controlled, and when it hits the ground, the impact is absorbed instead of causing it to collapse. As the tests continue, you can see how well Atlas handles tougher situations. It jumps onto platforms, clears gaps, and keeps its balance even when its stability is thrown off unexpectedly. One standout moment happens when the robot steps forward, lands, and then subtly readjusts its foot before continuing. Those tiny corrections might seem small, but they reveal just how precise the control software really is. Not every run is perfect either. Some attempts show Atlas stumbling, and at one point, it even loses part of its foot cover after a hard landing, which makes the whole sequence feel more real and experimental rather than staged. The collaboration with the Robotics AI Institute played a huge role in making this possible. Their whole-body learning approach allowed researchers to train behaviors in simulation and then transfer them directly to the physical robot. That means the same underlying methods can handle everyday walking as well as high-speed acrobatics. It's a big hint at a future where robots don't need completely separate programming for every single task, but instead can adapt using one flexible system that manages a wide range of movements.